This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what is the net AT production from aerobic metabolism of one glucose molecule via the malate-aspartate shuttle in the heart and liver? Answer: 32 net AT. Question: what is the net AT production from aerobic metabolism of one glucose molecule via the glycerol 3-phosphate shuttle in muscle? Answer: 30 net AT. Question: how many net AT are produced from anaerobic glycolysis per glucose molecule? Answer: 2 net AT. Question: can AT hydrolysis be coupled to energetically unfavorable reactions? Answer: yes, it can. Question: what effect does arsenic have on the net AT production during glycolysis? Answer: arsenic causes glycolysis to produce 0 net AT. Question: can you explain the process of aerobic metabolism of one glucose molecule? Answer: aerobic metabolism of one glucose molecule refers to the process in which the body converts glucose into energy by using oxygen. During this process, glucose is broken down into pyruvate and ultimately produces that via the malate-aspartate shuttle or the glycerol 3-phosphate shuttle. The net AT production can vary depending on the specific shuttle used, with the malate-aspartate shuttle producing 32 net AT and the glycerol 3-phosphate shuttle producing 30 net AT. Question: how does anaerobic glycolysis differ from aerobic metabolism? Answer: anaerobic glycolysis is the process by which glucose is broken down into pyruvate without the use of oxygen. This process produces only 2 net AT per glucose molecule compared to the 32 net AT produced via the malate-aspartate shuttle and 30 net AT produced via the glycerol 3-phosphate shuttle in aerobic metabolism. Additionally, anaerobic glycolysis produces lactic acid as a byproduct, while aerobic metabolism produces carbon dioxide and water. Question: can you explain the concept of AT hydrolysis being coupled to energetically unfavorable reactions? Answer: AT hydrolysis is the process by which AT is broken down into ADP and inorganic phosphate, releasing energy. This energy can be used to power other biological processes. In some cases, these processes require more energy than is released by AT hydrolysis alone, making them energetically unfavorable. By coupling the process to AT hydrolysis, the energy released by AT can be used to drive these energetically unfavorable reactions, allowing them to occur. Question: how does arsenic affect the net AT production during glycolysis? Answer: arsenic is a toxic chemical that can negatively impact many biological processes, including glycolysis. During glycolysis, arsenic interferes with the enzymes responsible for breaking down glucose, preventing the production of AT. As a result, arsenic causes glycolysis to produce 0 net AT, meaning no energy is produced. Question: what is the malate-aspartate shuttle? Answer: the malate-aspartate shuttle is a mechanism used in the heart and liver to transport electrons from the cytosol to the mitochondria during aerobic metabolism. It involves the movement of malate, an intermediate in the citric acid cycle, into the mitochondria where it is converted to oxaloacetate and then aspartate. Aspartate is then transported back into the cytosol where it is converted back to malate, completing the cycle. This process allows for the efficient transfer of electrons to the electron transport chain and the production of 32 net AT. Question: what is the glycerol 3-phosphate shuttle? Answer: the glycerol 3-phosphate shuttle is a mechanism used in muscle to transport electrons from the cytosol to the mitochondria during aerobic metabolism. It involves the conversion of dihydroxyacetone phosphate to glycerol 3-phosphate in the cytosol. G3P is then transported into the mitochondria where it is converted back to DHAP and then to the intermediate of the citric acid cycle. This process allows for the efficient transfer of electrons to the electron transport chain and the production of 30 net AT. Question: what are the byproducts of anaerobic glycolysis? Answer: the byproducts of anaerobic glycolysis are lactic acid and heat. Lactic acid is a byproduct of the conversion of pyruvate to lactate. It is usually removed by the liver, but in cases when the rate of production exceeds the liver's ability to remove it, it accumulates in the muscles and causes muscle fatigue, pain, and cramps.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the first aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.